And so that is the notes. So if you like, you can write the note for E vector. E is in the orbital plane, and E vector normal to the H. The third one I want to talk about is the conservation of the mechanical energy. And that one will give us the definition of the shape of the orbit. So from the equations of the orbit and R dot plus mu plus V equal to 0, and then they rewrite this one. R simply is equal to V dot plus mu over R3 R equal to 0. Okay, so simply I just rewrite the first term in terms of the derivative of the velocity. So now I want to take the V dot and in the product with the equation of the orbit, we see what happens. Okay, again, I simply take the inner product with these orbital equations with the velocity we see. So basically here we have this one equation. We have two terms on the left hand side. One is V dot this one. Okay. So this one, how can we calculate? And we keep it. And for the second one is we calculate V dot R. V dot R we can try is this. We choose the corner systems and say R equal to R times ER, the corner systems. And V in the corner systems is R dot ER plus R theta dot E theta. So that is it in coordinate systems. So therefore, V dot R can be described by R dot. Okay. And for this one, we can calculate is this, and we can take in Tn in tangential normal corner systems. This one I need a little bit more. So this is our main focus, and this is our orbit. So say this is our satellite, and this is the tangential directions, so along which we take the unit vectors. And normal to these unit vectors, and that is the normal directions. We put the En. So this is what we call the Tn coordinates. In this coordinates, we can describe V equal to V et, because velocity is right in the tangential directions, so its magnitude multiplied in the unit vectors of tangentials. So here the V dot is the derivative that should be in the normal directions here, and so that is V dot Et ddt, Vet. So that one we take the chain rule. So that is v dot et plus v times d dt of et. And this one, if you remember in dynamics, basically this is going to the n direction. So this is the n direction. So that one is v dot et plus v square of rho en. Okay, so basically this is the center force component. The rho is the radius of curvature, and here that is pointing to here. So basically, you can replace rho by r. Sorry. Okay, so that one. So therefore, from here we have v dot v velocity. This one is v. Okay. So we plug in here. So now this one can be derived. The first term is v times the magnitude of velocity multiplied with magnitude of accelerations, and plus mu r3 and r dot equal to 0. Okay, and this one is equal to dt minus mu over r. Again, if you take the chain rule of this term, and you will get this one. And how about this? This one is the d dt of the 2v squared. Again, if you take the chain rule, then you take this one. So rearrange. So that means therefore d dt and v squared over 2 plus minus mu over r equal to 0. So therefore v squared over 2 minus mu over r equal to constant. This one, if you look at this carefully, the first term representing is, say, we know mv squared over 2, that's the kinetic energy of unit with mass. So here that is the unit mass. So here we define is the specific mechanical energy. And the second one representing is the potential energy. And in particular, that is the gravitational potential energy. Okay, so the whole term here basically is the mechanical energy. And again, for your learning, those derivations are not that important. For your learning, you need to know is you need to pick up those information. Here I summarized here. And for you, you need to know to calculate angular momentum, you have to take out this calculation, etc. And for mechanical energy, we have this one. And from here, I have few more notes for you. The first one, say if you want to calculate velocity, then what here you can describe is this. So you simply, starting from this equation, that simply is equal to 2e plus 2 mu over r. So this is the speed. And here we define the x. Escape speed. This is a particular term is when happens when E equal to 0. Okay, so when the total mechanical energy is 0, then we define the corresponding velocity is called the escape velocity, and that is equal to 2 mu over r. And what that means, escape speed. Here you just listen, and later we will kick in more information. If this is the Earth, and this is the center of the Earth, and this is the orbit of the satellites. For all the satellites which surrounding with the orbit, surrounding about the Earth, or for Earth is surrounding around the Sun, those orbits, the elliptical orbits, they have corresponding mechanical energy negative. As long as all the orbits are elliptic, which means making cycles, they are docking on the orbit of energy less than 0. Which means those objects, they will be trapped by its hosting objects. It won't be escaped. It will be surrounding forever, or landing crash. Okay. The escape, that means this object will be able to move, go to the infinity in the space, which means escape away from the attractions of this one. Okay. And if you would have this one to be escaped from the cyclic motion, then you must have this object be mechanical energy is equal to 0 per our definitions. And for all the, again, here we have, say, satellites 1 and satellites 2. Satellites 2 have an orbit farther away from the Earth. And in general here, I would say this is the E2, this is the E1. E2, for example, here is -2, and E1 is more negative, say -2. I hope you can get a sense. Okay, so that means the less negative, it will be possibly docking that satellite farther away from the attracting objects. So that is the common sense. And before we kick in more mathematics, and that's the common sense that hopefully you can build up quickly. Okay, and so today I will stop here, and we have 2 more. We have next time we're coming back, we have the note 2. For this one, then I will from there give you more sense about the shape of the orbit, the size of the orbit, and those information can be based upon this simple equation here. Okay? Okay, thank you.